Hello, and welcome to Earth Science B. Okay, so while I get this set up, I'll do some introductions. I am your teacher, John McNerney. You can call me Mister. You don't have to. I don't care. So for Earth Sciences B, we're going to look at a lot of systems. Systems are pretty much anything. It can be Earth as a whole. We call that the biosphere. Everything living inside of inside of the Earth is the biosphere, which it goes from the deepest oceans to the top of the atmosphere, really. So that's one big system. It also can go down to an anthill, or even the human body is its own system with many different microscopic systems making it up. So that's just important to think about. Systems don't always have to be big. Okay, so the Earth has some main systems that have to do with each other, basically. They interact with each other and create things like climate and biodiversity, all sorts of good things. And there are cycles that we're going to talk about with these systems. Cycles are, pretty general, just the same with systems. Like day and night is a cycle, the seasons are a cycle, a tsunami is not a cycle, just for some heads up for the quiz there. But we're going to talk about the Earth systems. So we have the geosphere, which is essentially, if you remember learning about the core, the mantle, the crust, that's what the geosphere is going to be. It's one of its constituent parts is the lithosphere, which is the crust, which is just going to be all the rock and everything that moves due to plate tectonics or in plate tectonics. But the geosphere we're going to think about is everything: the core, the mantle, the crust, and how all that interacts with each other. The hydrosphere is going to be just simply all water on Earth. It gets into things like the cryosphere, where we talk about glaciers, but that all goes into the hydrosphere. So the cryosphere is just a little piece of the hydrosphere. So I want you to start thinking about things like that, how systems can look like it's one huge system, but it's made up of many other small systems. Like the hydrosphere has the cryosphere, and it's affected by the geosphere and the atmosphere, things like that. So start thinking about that. And then for cycles, for the geosphere, we're going to think about the rock cycle, how new rock is made, how rock is pushed up. That affects the geosphere. And for the hydrosphere, we're going to think about the water cycle. Transpiration moves water into the atmosphere. Precipitation, after condensation, makes water come down from the atmosphere. And so the hydrosphere is just all the water. So it can also be in the atmosphere. So that's just something to think about. Then we've got the atmosphere, which is affected by the carbon cycle and the water cycle, and the biosphere, which, as we said before, is all living things in one. So we're just going to talk about the Earth as a whole. And it's important to remember all systems interact and change with and to each other constantly. So the atmosphere is affected by the carbon cycle, which the biosphere emits a lot of carbon energy. So a lot of living organisms emit a lot of carbon energy. CO2, that's what we exhale. But you can also start thinking about plants, like they intake CO2 and release oxygen. So they're always affecting the atmosphere in a certain way, and plants are in the biosphere. All right, so we've got the atmosphere. In the atmosphere, we have these layers. It's not super important that you know it, but it's just a fun fact for you. So we've got the troposphere, which is from ground to 20,000 feet. We've got the stratosphere, which is 20,000 to 160,000 feet, and that's where you're going to see planes flying around most of the time. And the mesosphere, which is 160,000 to 280,000 feet, and the thermosphere, which is 280,000 to 350 miles out. So You don't really see the thermosphere because it's it's not as highly concentrated of particles as like the troposphere. You can see clouds and stuff going on there where you're not going to see much of that in the higher levels of the atmosphere. So the atmosphere is good. It protects us from radiation in the vacuum of space. Um, that's basically all those molecules that make these blue colors here are going to be reflecting radiation, and that's UV radiation. It's going to reflect that, and it protects us from the vacuum of space by kind of giving us a little livable environment with our own gravity, so we don't get sucked away and die. It provides a moderate livable climate. So when heat energy goes into the atmosphere, then it starts heating up, and we get our climates and our seasons, and vice versa. If it gets colder, then we're going to lose heat energy from the atmosphere. So what it does is it traps greenhouse gases. I'm sure you've all heard this before. That's like CO2. Technically, oxygen is one. Water is one of the biggest greenhouse gases. But what that does is it traps this hot energy basically, and it acts like a greenhouse where hotter energy is going to stay at the top, and then it's going to make convection currents, and we're going to get this cyclical energy change basically into the atmosphere. So it's affected by the biosphere, I told you before, from transpiration, that's water leaving like plant stomata into the atmosphere, or carbon emissions. So those are greenhouse gases. It's going to heat up the atmosphere. It's going to create more water, more extreme climatic events. So it is affected by and affects the hydrosphere due to evaporation and precipitation, as we talked about. So that's basically, you know, the water cycle has to do with evaporation going into the atmosphere, and then that water condenses at a certain point and comes back down. So the atmosphere is being affected by all these other systems. So we've got the geosphere. And the geosphere, let me move this guy, is basically just the physical layers of the Earth. You've got the core, the mantle, the crust, and you know, the inner core, the outer core. So you could just go ahead and take a look at this this picture here. If you don't already know the layers, then take a look at this picture and get yourself acquainted with that, because it's pretty important to know. But just know that the geosphere affects every other sphere because the inside of the Earth is a system in and of itself. So with more convection currents in the bottom, it increases, I don't know if you can see this, but like we'll get a convection current here in the asthenosphere, and it will move this plate this same way to the left, and that will affect all living organisms on that plate, and it will affect all the other spheres, all the other systems of the Earth. So we've got the hydrosphere. So I'll move this over a little bit. We've got the water cycle. It's just important to know that the hydrosphere is all of the water on the Earth, and it affects all other systems. Obviously, the biosphere, you know, plants, we need water to live. Everything needs water to live, essentially. There are some things that are good at not using water, but it's one of the life forces. And so then it'll affect the atmosphere up in the top. It will affect the biosphere. Water will interact with the geosphere, with vents and volcanoes. So the important thing to remember is that it's all together. All of the spheres interact with each other and change each other. So we've got the biosphere. This is an example of the carbon cycle. So essentially what's going on is carbon is being pushed up into the atmosphere over here, and then it interacts with water into the top of the atmosphere. Carbon is an acidic solution when combined with H2O, so it will be precipitated into the water. That water will create a more acidic environment, inside of the ocean, and so that's when we get ocean bleaching, is it because of increased carbon in the ocean, and that's due to the biosphere really interacting with the atmosphere and then interacting with the hydrosphere, which then again interacts with the biosphere. So, you know, take a look at this PowerPoint when you get a chance, and just look at the carbon cycle, the water cycle, maybe look up the rock cycle on your own time, just so you kind of have a better understanding of how all these things work with each other. And then here's just a more broad view of how all of these interact with each other. So we've got the geosphere here interacting with the biosphere, which interacts with the atmosphere, which then interacts with the hydrosphere. They all interact with each other to create this awesome planet that we live on. Here's another picture here that you can look at. It's just simplified. I urge you to take a look at the PowerPoint before you take the quiz, and then take the quiz, figure out what kind of questions it's going to ask, and then go ahead and look at the PowerPoint again. All right, so a thing that we talk about in science, and especially with systems, are feedback mechanisms. So we have positive feedback mechanisms and negative feedback mechanisms. So an example of a positive feedback mechanism, it doesn't have anything to do with the outcome, if it's like good or bad for the Earth. That's not what we're talking about. Positive feedback mechanisms generally create instability within a system, so they're not normally the greatest of things. So right here we've got a good example of a positive feedback mechanism. This is a glacial event, so we're going to call that an ice age. So we get a period of cooling, which leads to ice growth, which leads to an increase in albedo, which is reflection of the sun's rays. So with more reflection of the sun's rays, there's going to be less heat absorbed into the earth, and so then it's going to cool more, and then we're going to get more ice, and then we're going to get more reflection, we're going to get less heat absorbed and more cooling. So it's a positive feedback loop because it's continuously going in the same direction. That's what is important to know about that. And the same thing with warming. So we get a warming period, you get ice melts, you get more or less reflection, so the earth is going to absorb more sunlight or more energy from the sun. And then so more energy from the sun is absorbed. It's going to get hotter, more ice is melting, less reflection, more energy is absorbed. So that's kind of the trend that the earth is going on right now, so it's important to think about that. And then right here we've got a negative feedback mechanism. So essentially the negative feedback mechanism, it creates stability within a system. So we have the Gaia hypothesis, which means the earth will naturally try and create a stable environment. So that's what's going on here. We get cooling, we get decreased chemical weathering, so then you get stronger greenhouse gases being emitted into the atmosphere, and then you get warming periods, so then it stops cooling. So that's kind of what we're doing right now. We're in a negative feedback mechanism that starts a positive feedback mechanism of warming. So that's something to think about. All right, so this is the last slide. We have the Gaia hypothesis, which I told you the Earth tries to make it stable. The only problem is when humans are creating instability at a rate that the Earth cannot fix, then we start getting into problems like today. So glacial episodes, we're going to call those ice ages. That was like a positive feedback loop for cooling, is a glacial episode. And then one feedback mechanism that they talk about is the daisy model, and essentially that's with more heat energy into the system, we're going to get more white flowers reflecting because the dark flowers will absorb too much energy and die. And so then we're going to have more reflection. It's going to start a cooling period, and then that cooling period is going to make it so that the black flowers, the black daisies or dark daisies, actually succeed better because they'll be able to absorb more energy than the white flowers. And so then that's a negative feedback loop. So it just continuously goes in a circle from white and black. Okay, so let me know if you have any questions.